All right, so in this question, they are asking us to find the zeros of the polynomial and also the multiplicities of the zeros that we find. So the first thing that we know is that when we are trying to find the zeros, the procedure is we set our function equal to 0 because we're trying to figure out where y is equal to 0, the x-intercepts of the graph. And then because it's a polynomial, we need to factor it and then set each of the factors equal to 0. So again, find the zeros, we're setting the function equal to 0, then factoring. Now, when you look at the polynomial they've given you here, you'll notice that when you set this equal to 0, the whole thing about factoring is already done for us because we already have the parentheses, and so that means that we can just go straight to setting each of these factors equal to 0. Now, we talked about this a little bit in the previous problems. When we set each of the factors equal to 0, you can easily get rid of the fourth power in this case by taking the fourth root of both sides. And you're really just focused on whatever is in parentheses, setting that equal to 0. So because it's already factored, we set the factors equal to 0. We could take the fourth root of both sides, and then we would get x plus 1, or x plus 1/2 is equal to 0. And to solve that, we would just subtract the 1/2. Again, because it's a linear equation, we would start by subtracting the 1/2, and that would isolate our x for us. So that tells us that one of the zeros of this polynomial is negative 1/2. Now, our m, our multiplicity that we're trying to find here, remember that is the degree of the factor. So if we go back to where we got this negative 1/2 from, it came from a degree of 4, so m would be equal to 4. And that would tell us that because it is even, that it will touch and turn at that x-intercept. So it will touch and turn, because it's an even multiplicity, at the 0 of negative 1/2. All right, so from the first factor here, we get negative 1/2. It's a 0. It touches and turns at x is equal to negative 1/2. Now, if we repeat this procedure for our second factor, we would set we would set the x squared plus 3 equal to 0. Now, here, you notice you don't have a linear equation. You have an x squared, so that means we have a quadratic equation. Now, we can start to isolate this x squared by subtracting 3 from both sides. And then to undo that square power, we would need to take the square root of both sides. Now, when we take a square root of both sides, because we have a 2 power, we need to have 2 answers. So we add a plus or minus, and that gives us plus or minus square root of negative 3. Now, when you simplify this negative inside of the radical, the even square root, is going to become an I. So we really are finding that the 0 is plus or minus I square root of 3. Now, this might not seem like a big issue when you're solving an equation, but remember what we are trying to do here is we're trying to find an x-intercept. So we're trying to find on the x-axis where the graph is crossing. So when we found negative 1/2, that was telling us that the graph was going to touch and turn. There was going to be a point on our graph at negative 1/2. Now, when you think about plotting I square root of 3 on the x-axis, where on earth are you going to put that thing? Because all of these x values are real. And so because all of these x values, all the y values are real, we have to ignore this x is equal to I square root of 3 and say that the only 0 for us is this negative 1/2. So again, anytime you set the factors equal to 0, solve, and get an imaginary number, we always ignore those imaginary numbers if we are talking about a function. If it was just solve this equation, we would say it's a solution. But when we're talking about a function, we will ignore those imaginary I numbers, and so this negative 1/2 is our only solution.